Welcome back to The Explainer. So glad you're here because today we are tackling one of the most talked about, truly transformative technologies of our time. We're officially on day 3 of our AI learning series, and today's focus is demystifying exactly how large language models actually work. You know, you hear the acronym LLM everywhere these days, but behind all the buzzwords, what is actually going on under the hood? Well, today we're going to strip away the magic and look at the actual mechanics of the tech.
Here's our agenda for today. We'll hit 1. The phone keyboard analogy. 2. Defining large language models. 3. Analogy versus actual tech. 4. The core mechanism. 5. Why your prompt matters. And 6. Key takeaway.
All right, Section 1, the phone keyboard analogy, a familiar everyday AI.
To really wrap our heads around advanced AI, we need to anchor it to something you probably use dozens of times a day. Think about your phone for a second. You open up a text message, and you type the words, "I am going to..." Look at the screen. What word does your keyboard usually predict before you even finish typing? It probably suggests words like work, school, or the office, right? Hopefully preventing you from sending anything too embarrassing in the process.
But how's it actually pulling that off? The absolute crucial point here is that your keyboard doesn't actually know where you're going. It has zero awareness of your actual physical destination. Instead, it's just following 3 simple steps. 1. It looks at the text you've already typed. 2. It uses patterns it's learned from your past typing history. And 3. It predicts the most mathematically likely next word based on that current context. It's literally just playing a very fast game of pattern recognition and prediction.
Section 2. Defining large language models, scaling up the prediction engine.
So what happens when we take that exact same predictive idea from your phone and scale it up enormously? Well, you get a large language model, or LLM. It's basically a massive AI neural network trained on a staggering amount of text to learn complex language patterns and predict what comes next based on context. Instead of just learning from your personal group chats, it's learned from a massive chunk of the internet. And hey, quick technical note here. Technically, it predicts little pieces of words called tokens, not necessarily whole words. But don't stress about that just yet. We'll dive deep into tokens in a future explainer. For now, just think of it as predicting the next piece of the puzzle.
Section 3. Analogy versus actual tech. Mapping the keyboard to the AI.
Let's explicitly map our everyday keyboard analogy directly over to generative AI to see the actual engineering here. The simple act of autocomplete perfectly mirrors the complex architecture of an LLM. In our keyboard analogy, what you've typed, that's what AI engineers call the context. The keyboard suggestion, that's the prediction. The patterns learned from text, that represents the training phase. And generating what comes next, that is the absolute core mechanism of the model. It's the exact same fundamental concept, just operating on a wildly different level of scale and complexity.
The real difference lies in that scale. Your phone keyboard relies mainly on a very small amount of recent context, maybe the last few words or the current sentence. A modern LLM, on the other hand, processes and relates information across a massive context window. It can remember and connect ideas across an entire prompt, a huge document, or a completely extended back-and-forth conversation. This massive context window is exactly why its responses feel so incredibly coherent and, frankly, highly intelligent.
Section 4. The core mechanism. Busting the database myth.
Let's look at exactly how these models generate text. This is the internal workflow step by step, and it's a surprisingly simple loop driving the entire engine. Step 1. Use the available context. Step 2. Predict what comes next. Step 3. Continue generating. It literally just repeats this cycle over and over and over, predicting one token at a time until the entire response is complete.
Now, because of that loop, we face a critical limitation, and this is a huge misconception. An LLM is not looking up correct answers from some giant database. It's not a search engine pulling files from a hard drive somewhere. It generates text purely based on learned patterns and the available context. This is exactly why an LLM can produce a highly convincing answer that is entirely 100% wrong, a phenomenon you've probably heard called an AI hallucination. It's simply completing a pattern that looks mathematically correct to it, even if it's factually bogus. Now, to help mitigate this, modern LLMs receive additional fine-tuning and training specifically to follow instructions, stick to the facts, and actually produce useful responses.
Section 5. Why your prompt matters. Applying the tech to the real world.
Understanding this whole prediction mechanism completely changes how we should actually use this tool. Think of prompting as giving precise instructions to an expert. If you just type book into an LLM, you're giving the model basically zero context. A vague instruction like that leaves the prediction engine with millions of possibilities. It might predict flight, hotel, meeting, or restaurant. The output becomes totally unpredictable and unhelpful because the context is just too weak.
Contrast that vague prompt with this highly specific one. Book a flight from Chennai to Delhi for tomorrow morning. Bam! By providing a larger, precise context window, you dramatically narrow down those prediction possibilities. You're actively guiding the model's mathematical probabilities toward exactly what you need.
So, the absolutely crucial rule of prompt engineering is this. Better context leads to a more focused prediction, which leads to a much more useful output. Giving the model more information restricts its learned patterns to only what is relevant to your specific goal. You are basically setting the guardrails for its prediction engine.
Section 6. Key takeaways. Wrapping up day 3.
Let's lock in today's learnings. At its absolute foundation, an LLM is basically a massively scaled-up version of the autocomplete on your phone. The core mechanism is surprisingly simple. Use the context, predict the next piece of text, and continue generating in a loop. Because it relies entirely on context to make these predictions, better context will always lead to better outputs. Now tomorrow, for day 4 of our AI learning series, we're going to dive one level deeper. We're going to explore the specific technical architecture that makes all of this incredible prediction possible, the transformer.
I want to leave you with this thought today. The very next time you're texting and your phone automatically suggests your next word, take a second to really look at it. You are holding a simple, everyday glimpse of the exact same idea behind how the world's most powerful AI models generate language. So seriously, what word does your keyboard usually predict before you finish typing? Think about it, and I'll see you right back here in the next explainer for day 4.